Hi everyone, welcome to Sumanth tutorial. In the last session of our class, we have solved the problem related with the circles. Now, today regarding the circle itself, a new concept that is tangents and intersecting chords that we'll discuss and we'll solve few problems related to that in this session. Now, before directly moving to the problem, few property you should know so that it will be helpful to solve the problem related with the tangent of a circle. Here, first and foremost, we know that a circle, if a line is there, if you draw a line near to a circle, there is a gap in between that. One way to draw. Second thing is, if there is a circle, if you draw a line that intersects the circle at only one point, such a line is called as what? A tangent. That is called as what? A tangent. And then same thing if for a circle, if you draw a line that intersect the circumference of a circle at 2 points, then it is called as what? Secant. Okay, this is tangent and then this is a secant. Now here, based on this tangent, we are solving the problem related to that. There are two properties particularly now you have to learn, that is a line that is drawn from the radius to the tangent, nothing but the point at which the tangent will touch is called as point of contact. Same thing here, a line that is drawn, nothing but the radius with the tangent, the angle formed between the radius and the tangent is always perpendicular to each other. Nothing but it is equal to 90 degree. Got it now? This is one property. Nothing but the angle formed between the radius and the tangent is equal to 90 degree. The second thing that you have to learn is, if there is a circle from an external point, if you are drawing the tangent, for example, I will take this point as P. If you draw a tangent, how many tangents you can draw to this circle with the given point P? Here one is, you can draw one tangent, yeah, I'll mention this as A. And second, here also there is a space in which you can draw another one tangent, that is B. I will mention this as B. So, how many tangents you can draw from a point to the given circle is two tangents we can draw. Here AP is one tangent, BP is one tangent. According to the property that I have explained, if O is the center, then angle OAP is equal to 90 degree and same time angle OBP is also equal to 90 degree. Okay. Now, second thing is, the line AB is equal to BP. AP is equal to the length, the distance AP is equal to the distance BP. Okay. Next thing is, if you join OP, then angle AOP is equal to angle BOP. Angle AOP is equal to angle BOP. Okay. Same thing here also. Angle APO is equal to angle BPO. Angle APO is equal to angle BPO. Along with this, another one thing is there that you have to remember, as you see this one, OAPB, it look like a quadrilateral, no? OAPB is a quadrilateral. Here, the opposite angles, nothing but if you add angle A and angle B, both are equal to 90 degree. 90 plus 90 is equal to how much? 180 degree. Then, what about the sum of the remaining two angles? So, if you add the remaining two angles, then angle OAB plus angle APB is equal to 180 degree. This one you have to keep in your mind. Okay, sum of the angle formed at the center and at the exterior point, nothing but the tangent point what we have taken. If you add the angle between these two, then it will be equal to how much? 180 degree. These properties are these things you should keep in mind to solve the problem related with the tangents and intersecting chords. Here the question is given as, in the given figure, an isosceles triangle ABC. Here ABC is a triangle inscribed in a circle with center O. PQ is a tangent given here to the circle at C point. OM perpendicular to the chord. So this OM is perpendicular, nothing but it will form an angle 90 degree. Now, and angle COM is equal to 65 degree given. COM is equal to how much? 65 degree is given. Find angle ABC. This one you have to find. Second you have to find BAC. This angle you have to find. And then again you have to find the angle BCQ. BCQ. This angle you have to find. Okay. Now, first thing is ABC to find. So here children, OA is equal to OC. So OA is equal to OC, nothing but radii of a circle. And right here, OA is equal to OC, the radii. By that, and then next OM forms perpendicular with AC. Therefore, this is also equal to 90 degree and this is 90 degree. What will be the angle of this? This is also equal to how much? 65 degree. So by that angle OAM is equal to angle OCM that is equal to 65 degree. Therefore, by this, what is the total angle of AOC? We can write AOC as angle AOC is equal to 65 plus 65. It is equal to 5 plus 5, 10. Carry 1. So, 6 plus 6 is 12 plus 1, 13. So, it is 130 degree. Okay. By this, is it possible for us to find the B? Because of angle formed by the same segment is the angle formed by the same segment. Here one is at B the circumference, one is at the center. So therefore by that we can apply as angle ABC is equal to half of angle AOC. So that is half into, what is AOC? 130 degree. That is equal to 2 6 are 12, 2 5 are 10. So that is angle ABC is equal to 65 degree. So here we can write angle ABC as how much? 65 degree. Okay. Now next, what to find? Angle BAC to find. So if here AB is equal to AC, that is the data given here. So by that, so angle B is equal to angle C, therefore it is equal to 65 degree. Can we add this also equal to how much? 65 degree. So therefore apply the property of sum of the angles of a triangle is equal to 180 degree. By this we are able to find angle A. By this angle A plus angle B plus angle C is equal to 180 degree. So here we don't know. So this is 65 plus 65 is equal to 180 degree. So angle A is equal to 180 minus 65 plus 65 is 130 degree. Therefore, it is equal to 50 degrees. So, what is angle A? It is 50 degrees. So, by this we are able to find angle BAC as equal to 50 degree. Any doubt in this? No, no. I'll rub this part to solve the third concept, that is BCQ. The third one, to find BCQ. Listen children, I'll write here as angle BAC is equal to BAC is equal to 50 degree. Angle BAC is equal to angle BCQ is equal to 50 degree. So you may get confused why I have written this one. Why? Because it is based on the rule that angle formed by a chord, nothing but BC is a chord here. So by this an angle is formed at A is equal to the angle formed by the tangent here, nothing but the angle formed by the tangent. So as both are equal, we can write the angle as BCQ also equal to 50 degree. This completes this problem. Okay, now, so you may get confused with this. So one more example I'll take based on that I'll explain to you. For example, this is a triangle PQR. PQR. At the point R, an angle, a tangent is formed. That is EF is the tangent formed. So, if it is asked you to find the angle QRF, then if you are knowing this angle, directly you can write as angle QPR is equal to angle QRF, because the angle formed by the chord is equal to the angle formed by the tangent at the given point. Okay, is it clear for you? So here children, I have written question mark here. Instead of that, if it is x, I will write. Then this is also equal to what? X only. Nothing but we can write angle QPR is equal to angle QRF, that is equal to x. Make a note of this. Remember this until your exam will finish. The next question is ABCD is a cyclic quadrilateral. So ABCD is a cyclic quadrilateral in which BC is equal to DC given and EF is a tangent at A. Next is angle CBD is given as CBD is 43 degree. Angle ADB is 62 degree. Find angle ADC. Nothing but what to find here in this cyclic quadrilateral. You have to find angle, which one? The total angle ADC you have to find. Okay. Next, what you have to find next here is angle ABD. ABD. This one you have to find. Then next, at last you have to find the angle that is formed here. Okay, now for this, what to do? ADC, total angle we have to find. See children, as BCD is looking like a triangle. Is it? No, it is looking like a triangle. So here these two sides are equal, means the angles are also equal. So therefore, this is also equal to 43 degree. By this, can we find angle ADC? Nothing but angle ADC is equal to angle ADB plus angle BDC. So therefore angle ADB is how much? 62 degree plus 43 degree. So that is equal to 3 plus 2 is 5, 6 plus 4 is 10. It is 105 degree. What is angle ADC equal to, children? It is equal to 105 degrees. So we have find the answer for this one. Now second one, what it is given? We have to find the angle ABD. Here as ABCD is a cyclic quadrilateral, is it no? According to that rule, what is angle, sum of angle ABC and angle ADC equal to? So angle ABC plus angle ADC is equal to 180 degree, is it no? Because of cyclic quadrilateral. Okay. What is angle ABC? So we don't know. I'll write as it is as ABC only, plus what is angle ADC? It is 105 degree. 105 is equal to 180 degree. So angle ABC is equal to 180 minus 105, that is equal to 10 minus 5 is 5, 7. So it is 75 degree. Is this the answer for the second one? No. What we have to find? We have to find only the value of ABD. For that purpose, what to do? Angle ABC is the angle ABC is equal to sum of angle ABD and BDBC. Therefore, here I can write as it is equal to ABD plus angle DBC. Therefore, angle ABC is 75 degree is equal to, what is angle ABD? We don't know. What is angle DBC equal to? It is 43 degree. Just subtract this one. Therefore, angle ABD is equal to 75 minus 43. That is equal to 5 minus 3 is 2. 7 minus 4 is 3. That is 32 degree. So the second answer is how much? Angle ABD is equal to 32 degree. Okay. Now the next thing, last one, that is angle FAD is given. How to find angle FAD? In the last problem, what the rule that we have applied, same rule we will apply here also. That is angle FAD is equal to angle ABD. ABD, what is the angle here? It is equal to 32 degree. Okay. So it is based on the alternate segment property that says that the angle formed by the tangent nothing but with respect to the point here is equal to the angle formed by the same chord, nothing but AD is the chord at the other segment. So that is the rule it will show. By this we can write this angle, the angle here is equal to this angle, nothing but angle FAD is equal to angle ABD. Got it? In the figure, O is the center of the circle. So O is the center. PQ and PR are tangents. PQ and PR are the tangents, and angle QPR is given as how much? Angle QPR is equal to 70 degree they have given. Calculate QOR, nothing but this one we have to find. Next QSR, this one we have to find. Already in the starting of the lesson, I have explained that the opposite angle, sum of the opposite angle is equal to how much? 180 degree. The sum of the opposite angle is equal to 180 degree. By that, we can write as angle QPR plus angle QOR is equal to 180 degree. Therefore, QOR is equal to 180 minus, what is the angle this one? 70 degree. That is equal to 0, 1, 110 degree. What is the value we got for angle QOR? It is equal to 110 degree. So, this angle is equal to 110. Now, what to find? We have to find angle QSR. In order to find this one, what will do the rule as? I will take the reflex angle of this. I will find this angle. By that, I will make it into a half of this one so that I will get this angle. Are you understanding? So, by that, how to write as the reflex angle QOR is equal to, what is the total angle, children? That is equal to 360 degree minus 110 degree. The internal angle is how much? 110. So this is equal to 0. 6 minus 1 is 5. 3 minus 1 is 2. So we got this angle is how much? 250 degree. In the last class I expand this one also. So here, therefore, angle QSR is equal to half of the reflex angle, QOR, that is equal to half into 250 degree, that is equal to 2 1s are 2, 2 2s are 4, 2 5s are 10, it is equal to 125 degree. How much it is? It is equal to 125 degree. So this is how we are able to find the value of QSR. Next question is, two cards AB and CD. See here children, AB and CD of a circle intersect externally at E. E is a point, the external point where the two cards are meeting. So here we can't take this as a tangent because it is not touching at one single point. So this is the card which has been extended. If EC, the length of EC is 2 cm, EA is 3 cm, AB is 5 cm. What you have to find? You have to find the length CD. Okay. So there is a rule here which you have to understand as when two cards touch externally, when two cards here, which one? A, B and CD touch externally at E, at that time we can apply the rule as EA into EB, EA into EB is equal to EC into ED. Are you understanding? The total length EA into EB is equal to EC into ED. Okay. So by this, what is EA? As it is, I write into. EB is the sum of EA plus AB is equal to EC into EC plus ED. Now, what is EA length given? It is 3 into EA is 3 plus EB is 5. It is equal to 2 into EC is 2 plus ED. Are you understanding this concept? Now, 3 into, what is 3 plus 5? It is 8 is equal to 2 into, what is 2? Again we can't change that one. We'll write as it is. Now, 3 into 8 by 2 is equal to 2 plus ED. 2 4s are, 4 3s are 12. This will minus 2 is equal to ED. Therefore, the length of ED is equal to 12 minus 2 is 10 centimeter. What is the unit is given that we have to write is equal to 10 centimeter.
Then
in the figure, AC is a tangent to the circle. So I have taken this as what? 90 degree. If angle ADB is equal to 55 degree, find x and y is given. Find x and y to find. How to find this one? First and foremost, look at the figure and now just see this one as ABD. Is this looking like a triangle? ABD, one we know that is 90 degree, another we know as 55 degree. Can we calculate B? Yes, by that. So here in triangle ABD, angle ABD plus angle BDA plus angle DAB is equal to 180 degree. What is angle ABD? We don't know. So ABD, let us leave as it is. What is angle BDA? BDA is 55 degree plus DAB is 90 is equal to 180 degree. So angle ABD is equal to 180 minus 5, 9 plus 5 is 14, 145 degree. So that is equal to 10 minus 5 is 5, 3, that is 35 degree. What the angle we got? Angle ABD as? It is equal to 35 degree. So now next, what to do to find the value of y here? To find the value of y, look here children, this is circle is given, this is the point A and this is the, look here, I will draw here now at the upper side. So here, as you see this one same diagram, here A is a point, E is a point. If you think this is a third or a segment, then here the angle formed, here it is y and this is 35. Can we apply the rule here? Angle formed by the same segment at the center. Here at the center is twice the angle formed at the circumference. So by that, what we can write? Angle AYE, or we can write as AY instead of y, we will write as O. Angle AOE is equal to twice the angle ABE. Can we write as? Therefore, it is equal to 2 into 35. What is 35 2 times? It is 70 degree. Angle AOE, nothing but y, is equal to how much? 70 degree. So we have now knowing the value of y as 70 degree. So now what to find? We have to find the value of x. Again see here children, as we look here, so is OAC. It is looking like this now, nothing but a triangle again, and here at A it is 90 degree, at O it is 70 degree. So at C nothing but x we have to find. Again can we apply the same rule? So triangle property, therefore by that, directly I will write here children, again I will not write the formula, again 90 plus 70 plus x is equal to 180 degree. Therefore x is equal to 180 minus, what is 90 plus 70 is equal to 160 degree. Therefore x is equal to 20 degree. This is how we can solve this complicated form problem in a simple manner. In the problem, in the figure O is the center of the circle. PR and PP. PR, this one PR and PT are the tangents to the circle and they are drawn from an external point P touching the circle at Q and S respectively. MN is a diameter given. So now angle PQM is given as 42 degree. Angle PSM is given as 25 degree. What are the things you have to find is, one is angle OQM, that is OQM, this angle you have to find. Then QNS QNS, the total angle we have to find. Then angle OQOS, this one we have to find. And at last we have to find QMS, this angle we have to find. First and foremost, remember the thing I explained you, the alternate segment theorem property. Based on that, what we can write here for this angle PQM is equal to angle QNM. That is equal to 42 degree because of alternate segment theorem. I explained to you already in two problems. Remember that. An angle P, nothing but this is also equal to 42 degree, and same thing, angle PSM is equal to angle SNM. So SNM, that is equal to 25 degree. Remember that, based on alternate segment theorem. Now children, so then this is also equal to how much? This is also 25 degree. So what is the first problem given? To find angle OQ, nothing but OQM to find. Children, already I explained you that the angle formed between the radii and a tangent is equal to how much? It is equal to 90 degree. By that, so the first answer is angle OQP is equal to sum of OQM plus MQP. Nothing but this is equal to 90 degree is equal to OQM, as we don't know, OQM plus what is the MQP? It is equal to 42 degree. By that, angle OQM is equal to 90 minus 42, that is equal to 10 minus 2 is 8, 8 minus 4 is 448 degree. Angle OQM is equal to 48 degree. The first answer is finished. Now next, what to find? To find QNS, nothing but directly we can find because of the sum of that one, nothing but angle QNS is the sum of 42 degree plus 25 degree, that is equal to 5 plus 2 7, 4 plus 2 6, that is equal to 67 degree. So this is total angle is how much children? It is equal to 67 degree. Okay, we have finished this also. The third one to find, already I have explained to you that the angle formed at the center is double the angle formed at the circumference of the circle. So by that we can take angle QOS is equal to twice the angle formed at the circumference QNS, that is equal to 2 into 67 degree. 2 7s are 14, carry 1, 2 6 are 12 plus 1 13, it is 134 degrees. So QOS is equal to 134 degree. So what is the last thing to be found? That is QMS, nothing but QMS. As you see children, is MS and Q is looking like a cyclic quadrilateral. So according to that, the sum of opposite angles is equal to how much? It is equal to 180 degree. By that, I will write as already we are knowing the end angle, no? By that, QMS plus QNS is equal to 180 degree. QMS is equal to 180 minus 67 degree. So 10 minus 7 is 3. 7 minus 6 is 1. This is 113 degree. This is how we can solve this problem in an easy manner. One thing, you have to remember this alternate segment theorem. So that here in this session, we have just learned only few concepts, that is the tangent and intersecting chords. Few problems we have solved. Still complicated problems are there that we will discuss in our next session. Till that, keep in touch with us and then learn well. you also solve the problem so that you will get an idea how to solve the still complicated problems. Thank you for watching the video.